Okay, so today we're going to talk about the very last unit of, or the very last lesson of our probability unit, and we're going to talk about conditional probability. Okay, so we're going to use the given tables in the following examples to answer some questions. Okay, so example number 1 says that the table shows the number of tropical cyclones that formed during the hurricane season from 1988 to 2004. So first we have to understand this table in order to be able to use it to answer these questions. Okay, so we have all of the types of tropical cyclones. We have a tropical depression, storm, and hurricane. Okay, then it's separated by hemispheres, northern hemisphere and southern hemisphere. Okay, so problem number A says to find the probability of a tropical depression randomly occurring. Okay, so again, if we're thinking of probability, it's a fraction. That is chance over total. Okay, so what's the chance that we had a tropical depression? Okay, well, we had tropical depressions that happened in the northern hemisphere and the southern hemisphere. Does it specify which hemisphere I should be worried about? Okay, no, it doesn't. So I need to add both of the hemispheres together. So 199 plus 18 is 217. So our chance of this tropical depression randomly occurring is 217. And then total. Okay, our total comes from the total of all of these storms. Okay, all of the storms. So to do that quickly, I could add straight across on all of these, add the hemispheres together. So if I'm looking at the tropical storms, 398 plus 200 is 598. Okay, and then for the hurricanes, 545 plus 215 gives us 760. And then all I need to do is add up all these totals here. So the total number of storms that we're talking about are 1575. So there's our total. Okay, so then if we reduce that as a fraction, we should be getting 31 out of 225. Okay, and if you calculate the percentage of that occurring randomly, it is 13.78%. Okay, B. B says given that a tropical cyclone is located in the northern hemisphere, what is the probability that it is a hurricane? Okay, to be able to find the probability of what it's asking us to do, we have to understand what it's asking for. Okay, so it's asking for the probability of a hurricane that is located in the northern hemisphere. Okay, so that means that the only column I am worried about is my northern hemisphere column here. Okay, so looking at the northern hemisphere column, my chance of having a hurricane just in the northern hemisphere is 545. Okay, then total. Again, I'm only focused on the northern hemisphere. So what is the total number of cyclones that occurred in just the northern hemisphere? Okay, well, we could quickly add those together. If we did 545 plus 398 plus 199, that gives us a total of 1,142 storms in just the northern hemisphere. Okay, then if we type that in the calculator, to simplify our fraction, I am getting that that fraction does not simplify. And then if you'd like to know the percentage of it, 47.72% chance that we had a hurricane that was located in the northern hemisphere. Okay, part C says find the probability that a hurricane is in the northern hemisphere. Okay, so again, we're looking at our table. Let me clean our table up a little bit here. Okay, and this time they're telling us first that we're only concerned about the part of the table that has to do with hurricanes. So this part of the table right here, okay, because they're talking about only hurricanes. Okay, then more specifically, they want to know what's the chance that that hurricane happened in only the northern hemisphere. Okay, well, looking at the table, our chance of that happening is 545 again. Okay, this time the total though, again, if we're looking at just hurricanes, our total is 760. So if we type that in the calculator to see if our fraction reduces, It will, and it reduces to 109 over 152. And again, if you'd like to know the percentage of that happening, 71.71% chance. Okay, last question here. It says, given that a tropical cyclone is a tropical storm, what is the probability it is located in the southern hemisphere? Okay, so first they want us to focus in on just tropical storms. So just this part of our table right here that I'm highlighting in this green. Okay. Then they're asking us specifically to focus in on, let's see, the southern hemisphere. So this guy right here. So our chance of having a tropical storm that occurs only in the southern hemisphere is 200 out of a total number of tropical storms of 598. Okay, so if I type that in the calculator to see if it reduces, I am getting that it does to 100 over 299. And again, percentage of that is 33.44%. Okay, let's continue on to the back. And we have a few more examples to take a look at. Example 2 says the table shows students' attendance at a school festival based upon their class. So again, let's understand this table. So straight across, they're talking about seniors, the number of seniors attending the attending the festival, those not attending the festival, and then the total percentage out of the whole. Okay, then the juniors, again, percentage attending the festival, not attending the festival, and then the total number of juniors out of the whole. Okay, then we can also look at our table this other way. This is the percentage attending the festival. This is our percentages then not attending our festival. Okay, A says, what is the probability that a student plans to attend the festival given that that student is a junior? Okay, so they're asking us on this one to just focus in on our juniors. So these guys right here that I'm highlighting in yellow. Okay. Specifically, they want us to focus in on the number of juniors that are attending the festival. So these guys in particular right here. Okay, so what is our percentage that are attending? 22.6%. Okay, out of a total how many juniors? 52.5%. Okay, so if we type that in the calculator, I'm getting 43.05% are actually attending the festival. Okay, B, what is the probability to the nearest percent that a student surveyed is attending the festival? Okay, so this one, they have actually already calculated our probabilities of people either attending or not attending the festival. That's what they're giving to us right here in this column for totals. Okay, so they're asking to the nearest percentage, students surveyed that did attend the festival. That means I'm looking at seniors and juniors that attended the festival. So to the nearest percentage, 43% of them attended. So I don't even have to set up a probability, a fraction at all for myself because they already calculated my proportions, or I'm sorry, my probabilities for me. I just have to know how to interpret them from the table. Okay, last example. Example 3 says the table shows a sample of people who commute to work on a bus or on a train and whether or not they own a car. Okay, so again, let's understand our table. Bus, train, and our totals. Okay, then the number of people that ride a bus but have a car, the number of people that ride a bus with no car, okay, people that ride a train but also have a car, people that ride the train but have no car. Notice how I'm doing this. Okay, then our total number of people that have cars, total number of people that don't have cars. Okay, then total number of people that are in this sample. Okay, A says how many people surveyed ride the bus but do not own a car. Don't get thrown off on this problem. They're not even asking for a probability here. So all they're asking me to do is to look at my table and interpret the values that they've put in it. Okay, so I'm looking for people who first ride the bus. So that means I'm looking at this row of people right here. Okay, then specifically in that row, they ask us people that do not own a car. So the people that ride the bus with no car, 62. Okay, then B, how many people surveyed ride the train? So again, not asking for a probability, they want us to look at our table and interpret it. Okay, so looking at our table here, we're looking at people who ride the train. So here's people with a car and without that ride a train. Okay, and then do they ask us any kind of questions about whether the people on the train have cars or not? No, so that means all they're asking me for is my total. So 50 people meet that criteria. Okay, C, how many people surveyed own a car but ride the train to work? Okay, so now I'm looking at this column here, the I own a car column. Okay, and in that column, specifically, they want to know who ride the train to work. So of the people that own a car, the ones that ride the train are these 16 people right there. Okay, I'm just going to erase all of this real fast for us, clean up our table before we jump into these next few problems. Okay, D says to find the probability, okay, so now we're back to a fraction, that a person surveyed has a car given that they ride the bus to work. Okay, so first, they're asking us to look at people who are riding the bus. Okay, so this row right here. Here's all the peeps that ride the bus. Okay, and specifically, they want us to focus in on the people that have a car. Okay, so if I'm writing a probability, I need chance over total. So the chance that you ride the bus, but you also own a car is 8. Out of the total number of people riding the bus are 70. So if I reduce that fraction, I am getting it to be 4 over 35, or 11.43%. Okay, last one, find the probability that a person surveyed rides the train given that they own a car. Okay, so this time they're asking us about people that own a car that specifically then ride the train. So these guys right here. So my probability of people riding the train, my chance that they're riding the train is 16. Out of the total that own cars is 24. Okay, and when we reduce that fraction, I am getting 2/3, or 66.67%. Okay, you can go ahead and get rolling on Unit 8.4 homework.